Breadth first search means the traversal will go in the order of levels. First S, then A, B, then C, D, G, H. That's the next level. C, D, G, H. So we'll implement the same using a queue. So I'm doing it in a single step. So first one, S is taken inside the queue. I think this is the front of the queue and this is the rear end. Next, I'm going to dequeue this S and I'm going to find the adjacent nodes of S. So the adjacent nodes are A and B. So NQ it inside the queue, A and B. Next, I'm going to dequeue the next element, which is A. So you know DQ operation will come from the front and NQ will come from the back. Next, after dequeuing A, I'm going to note the adjacent nodes of A, that is C and D. So I'm going to put it inside the queue. Next, I'm going to dequeue. While I dequeue, B will be coming out. So the adjacent nodes of B are G and H. So I'm going to NQ inside the queue. Next, I'm going to dequeue. The first element will be coming out. So C will be coming out. So the adjacent nodes of C are E and F. So I'm going to NQ E and F. Next, I'm going to dequeue all the elements which are in the queue. So next, D will be coming out. So D is not having any adjacent elements. Next, G is coming. Next, G will come out. Next, H. Next, E and F. So this is called as the breadth first search. So this is a type of graph traversal. So another type of graph traversal is DFS, that is depth first search. So here what we are going to do is we are going to analyze the nodes and explore each node individually. We are not going to adjacent nodes. First, if we go to one node, we are going to analyze each node completely. For example, we'll start from S, then we'll go to A. Any one we'll visit. We'll go to A. So usually going by alphabetical order is better. A. Now after going to A, I'm going to see the adjacent nodes of A. So first we will take B alone. So I'm taking B. Again I'm going to note the adjacent nodes. So B is having 2, but I'm going to go to only 1, D. Now this is visited. Now you have to backtrack and go and find what are the other adjacent nodes. So like this we are going to visit in the depth first search. We are going deep inside. For example, now for this one, if S is taken as known, next we'll go to A. Now A is considered as known and next we'll go to one of the adjacent nodes, that is B. So B is taken as known, next we'll go to one of the adjacent nodes, that is D. Now this is visited. Now it is not having an adjacent node, so we can go back. So we'll go back here. What are the adjacent nodes of B? E is the adjacent node of B. Go back to E. Next, again we'll go back and then will backtrack. Next, again from here, what are the adjacent nodes? C is the adjacent node. So we'll go to C. Again, the adjacent node of C is G. So we'll go to G. So again from here we can backtrack and move towards S. Now we are going to visit the next node, that is H. The adjacent nodes of H are I and J. So here we are going to I. Now we are going to find the node of I. The adjacent node of I is only K. So we are going to visit K. Then we are going to backtrack and go to the place which is unvisited. So from H we are having J as unvisited. So this is the order in which we do depth first traversal. So we are going to implement depth first search using a stack. And here we have an output box where we'll write the order of visiting. So first one we are going to visit the first node, start node S. Put it inside the stack. Now we are going to see the adjacent nodes. So S is visited. Mark S as visited. Next we are going to see the adjacent nodes of S, that is A and H. So first we are going to put A into the top of the stack. Next we are going to mark A as known and put it in the output box. Next we are going to see the adjacent node of A. So we are going to take only one at a time. So we are going to take B. So push it into the stack. Next we are going to mark B inside the output box. Next we are going to see the adjacent node of D. So D is one of the adjacent node, you put it inside the D. So mark D as node and put it inside the output box. Now here what we are going to do is, this D is not having an adjacent node, so we are going to pop out D. So take D, pop D outside of the stack. So D comes out and the stack will be like this, S. Next we are going to see so we visited D and we have popped out D. Next the top of the stack is B. So from B we are having D and E. So D is already visited. Next we are going to E. So mark E as visited, put it inside the output box and then put it inside the top of the stack. Now you are going to check the adjacent nodes of the top of the stack element E. It's not having any adjacent nodes. So what you are going to do is pop out this E from the stack. We are going to see the adjacent node of B. B is not having any other adjacent node, so we are going to pop out this B from the stack. So the node are S and A. Next we are going to see the adjacent nodes of top of the stack A. So that is B and C. So B is already visited. Next we are going to visit this C. So mark C as visited and just put it inside the output box and put it inside the top of the stack. Now we are going to see the adjacent node of C. The adjacent node of C is G alone. So what you are going to do is go to G, mark it as visited, put it inside the output box, then put G in the top of the stack. Next we are going to see the adjacent nodes of G. The item at the top of the stack is G. So we are going to see the adjacent nodes of G. G is not having any adjacent node, so pop G out of the stack. So we are having S, A, C. Now the adjacent node of C we are going to see, because C is the top of the stack. It's not having any other adjacent nodes, so pop out C. So we will be having S, A alone. Next we are going to see the adjacent node of A. A is not having any adjacent node, so pop A out of the stack. So we will be having S alone in the stack. Now we are going to see the adjacent node of S. That is A, already visited. Next is H. So mark H as visited, put it inside the stack, also put it inside the output box. Next we are going to see the adjacent node of H, I and G, but we are going to only one node at a time, so I. So put I inside the stack, also I in the output box, and mark I as node. Now we are going to see the adjacent node of this I, because it is the top of the stack. So adjacent nodes of I is K. So you put it inside the top of the stack and put it inside the output box also. Next we are going to check if the top of the stack has any other adjacent nodes. So it's not having adjacent nodes, so pop K out. S, H, I. Now we are going to see the adjacent node of this I. So I is not having adjacent node, so pop I out. S, H. Next for H we are going to see the adjacent node, because it is the top of the stack. H is having one adjacent node, that is J. So put it inside the output box and push it into the stack. Now we are going to see the adjacent node of J. J is not having any adjacent nodes, so pop J out of the stack. So S, H. Now H is not also having any adjacent nodes, so pop it out, and S is also not having any adjacent nodes, so pop it out and the stack is empty. Now this is the order it is visited. Output will give the order, but we are going to use the stack for backtracking purpose, and if we miss out any vertex which is unvisited.